Right now, as you watch this, there's a machine moving through absolute darkness. It's been falling for 49 years. No course corrections. No pit stops. Just momentum and the void. In November of this year, it will cross an invisible line 25 billion kilometers from home. One light day. The distance light travels in 24 hours, which means if you screamed at Voyager 1 today, your voice wouldn't reach it until tomorrow. And if it whispered back, you wouldn't hear it until the day after. This isn't just a milestone. It's a map of how impossibly small we are, and how far we've managed to throw a message anyway. Let's build a map. Let's show you what one light day actually looks like. The moon is far. 384,000 kilometers. It takes light just over a second to get there. Apollo astronauts needed 3 days. When Neil Armstrong spoke those famous words, there was a delay. A slight pause between Earth and Moon. 1.3 seconds. Barely. Noticeable. Mars, at its closest, is 55 million kilometers away. Light reaches it in 3 minutes. A radio signal from the Perseverance rover takes 6 minutes to get home. Controllers on Earth drive the rover by sending commands into the past, hoping their calculations are right. Neptune, the edge of what we used to call the solar system, sits 4.5 billion kilometers out. Light takes 4 hours to cross that distance. 4 hours of silence between transmission and reception. Voyager 1 is now pushing 26 billion kilometers, 5 times farther than Neptune. So far out that the sun isn't a sun anymore, just the brightest star in a sky full of stars. The solar wind has stopped. The plasma has changed. This is interstellar space. Imagine the solar system as a city. Earth is your apartment. The moon is across the street. Mars is downtown. Neptune is the edge of the suburbs where the streetlights end. Voyager 1 is past the city limits, past the farmland, past the state line. It's in a different country now, a country with no borders, no landmarks, no reference points except the distant stars that barely move. And it's still accelerating into nothing. 17 kilometers per second, 61,000 kilometers per hour. Fast enough to circle the Earth in 40 minutes. But out there, in all that emptiness, it might as well be standing still. 1977. 2 identical spacecraft built in a basement in Pasadena. Voyager 2 launched first, in August. Voyager 1 followed 2 weeks later on a faster trajectory. The mission was simple. Visit Jupiter and Saturn. Take pictures. Survive 4 years. Then die quietly. But they didn't die. They kept going. Voyager 2 swung past Uranus and Neptune. Voyager 1 took a different path, slingshotting north out of the ecliptic plane, aiming for interstellar space. The engineers hadn't planned for this. The spacecraft was overbuilt, sure, but not for forever. Just for a little longer than expected. Before it left the planets behind, the mission team did something unexpected. Carl Sagan convinced them to turn Voyager 1 around, to point its camera back toward the sun. And on February 14, 1990, from 6 billion kilometers away, just a quarter of a light day, it took one final photograph. The pale blue dot. Earth, suspended in a beam of scattered sunlight. Less than a pixel. 0.12 pixels, actually. Sagan called it home. He called it the only world we've ever known. Every human who ever lived. Every king. Every beggar. Every war. Every kiss. Every triumph and tragedy. All of it contained in that fragile point of light, barely visible against the vastness. After that photo, they shut the cameras off forever. To save power. To keep the mission alive. The instruments that could look outward were sacrificed so the instruments measuring the void could keep working, and Voyager 1 kept falling. In 2012, it crossed the heliopause, the boundary where the solar wind stops and interstellar space begins. The first human-made object to leave the solar system. Scientists watched the data change. The plasma frequency shifted. The magnetic field reoriented. Voyager had entered a place no probe had ever been, and it's still transmitting. 23 watts of power, the equivalent of a refrigerator light bulb, broadcasting across 26 billion kilometers of space. And we're still listening. One light day isn't just a number, it's a horizon. It's the point where communication becomes an exercise in patience. If something goes wrong with Voyager today, we won't know for 24 hours. If we send a fix, it won't arrive for another 24. A 48-hour conversation with a machine older than most of the engineers currently listening to it. And here's the thing. Voyager wasn't built for this. It was built with 1970s technology. An 8-track tape recorder for data storage, 68 kilobytes of memory, less than a single iPhone photo, 3 radioisotope thermoelectric generators that have been decaying for half a century, their plutonium-238 slowly fading like dying embers. The power output drops by 4 watts every year. Systems are being shut down one by one to keep the science instruments alive. The heaters went off years ago. The instruments are operating at temperatures colder than the surface of Pluto, minus 230 degrees Celsius, but they still work. The cosmic ray detector still counts particles. The magnetometer still measures fields. The plasma wave instrument still listens to the hum of interstellar space. Engineers have rewritten code, redirected power from backup systems, used attitude control thrusters that hadn't fired in 37 years, their fuel lines crusted with age, but somehow still functional. They've kept this thing alive through sheer stubbornness and brilliance. But the math is inevitable. Sometime between 2030 and 2035, the power will drop below the threshold needed to operate a single instrument. The transmitter will fall silent. The carrier signal will fade, and Voyager will continue, alone, without us listening. Which makes this moment, one light day, one of the last great milestones we'll ever share with it. One of the last times we can say, we are here, and it is there, and we can still reach each other across the dark. So what happens next? Voyager 1 will keep moving. In 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445. Not close enough to be captured by its gravity. Not close enough to matter to anyone watching from there. Just close enough to say it was there. A brief transit across someone else's sky. In 300,000 years, it will reach the edge of the Oort cloud, the true outer boundary of the Sun's gravitational influence. A shell of icy debris stretching halfway to the nearest star. And in a few billion years, long after the Sun has swelled into a red giant and swallowed the Earth, long after our planet is nothing but vapor in an expanding stellar atmosphere, Voyager will still be out there. A fossil, a time capsule, a message in a bottle thrown into an ocean no one may ever cross. Because bolted to its side is the golden record, a 12-inch gold-plated copper disc containing sounds and images from Earth. Greetings in 55 languages, music from Bach to Chuck Berry, the sound of rain, the sound of a mother's kiss, a diagram showing our location in the galaxy using pulsars as reference points. It's a message to anyone or anything that might find it. Not a plea for contact, not a call for help, just evidence. Proof that we were here, that we looked up, that we built something and sent it outward because we had to, because it's in our nature to reach. The odds of it ever being found are incomprehensibly small. Space is unimaginably vast. Voyager could drift for trillions of years and never come within a light year of another star. The galaxy could die and be reborn, and Voyager would still be falling through the ruins. But it doesn't matter, because the golden record was never really for them. It was for us. A reminder of what we could be, what we could build when we tried. A snapshot of humanity at its best, launched at a time when we desperately needed to believe we had a best. In November, Voyager 1 will reach one light day from Earth, 26 billion kilometers, a distance that takes light an entire day to cross. And somewhere in the dark, a machine the size of a small car, powered by the decay of plutonium, will keep transmitting, keep moving, keep carrying our message into the void. It won't stop. It won't turn around. It won't come home. It will just keep falling. Forever. And maybe that's the point. Maybe the map was never about where we've been. Maybe it's about how far we're willing to reach. Even if we never hear the echo. Even if the only answer is silence.